Today we're asking the question, will it erode? Keep watching to find out. In our previous episode, we stress tested various benchies made of different materials with aggressive media and a blasting cabinet. Be sure to check out part 1 first if you haven't seen it already. For our second test, we'll be shaking things up with a media tumbler. Media tumbling is useful for deburring and removing machining marks on CNC parts. Tumbling can also help soften edges and mitigate layer lines on 3D printed materials, such as with SLS Nylon 12. Usually we tumble parts just long enough for the required application. However, unfortunately for our benchies, we'll be prolonging the usual tumbling time.
We will be testing the same materials featured in the first part of the series, a mixture of 3D printed thermoplastics from FDM, SLS, and MJF, as well as resin-based materials from SLA, LSPc, DLS, and Polyjet.
We'll start off using ceramic media, which is a common choice for many of our tumbling applications. We'll check on the benchies around 2 hours of tumbling, and then continue tumbling for another 2 hours and evaluate them again. But instead of ceramic media, we'll be experimenting with using nuts and bolts, which should be a tougher medium. Let's get that tumbler loaded and see what happens.
Let's do a quick review of how our benchies look after 2 hours of tumbling in ceramic media. The powder bed plastics went from matte to an eggshell texture with media tumbling, which is a standard finish we offer at Xometry, but there's a reason we dye after the treatment. You can see how the tumbled blue part wore down to an eggshell finish. MJF polypropylene softened on the corners significantly. I thought it was interesting how the layers became present during tumbling. PLA honestly did not wear as much as I expected, but you can see the differences between our control on the left and the tumbled part on the right. You wouldn't even guess ULTEM has been in a tumbler for hours. The vibrant yellow on the controlled Polyjet makes the tumbled version look subdued. Staining was definitely present on the lighter materials after this test. Although maintaining clarity, the quick clear paint coat was worn away, as well as sharp edges and features on the SLA piece. This LSPc material had the most significant wearing of all our samples. This was especially present on the hull. Beyond some fading of the black dye, the TPU part retained a matte finish with some light wearing on sharp corners. We ran these parts for another 2 hours, but we're surprised to see little changes from the initial results. We decided to up the ante by both increasing the tumbling time to 48 hours and adding in sharp abrasive plastic media, along with various screws, nuts, and bolts for an extra abrasive environment.
Okay, so we just exposed these parts to over 48 hours of what I like to call media soup. We added a bunch of different abrasive medias, as well as a few nuts and bolts. I won't lie, the nuts and bolts may have stained all these parts, but overall we got some interesting results. And honestly, color me surprised. I was expecting to see some of these materials really wear away. And in most of these cases, they smoothed out pretty well. You know, if I looked at some of these parts here, I have a pretty decent gloss coming through. But some did stand out more than others. On my photopolymer side, I did see that some of the softer materials had more rounded features. Polyjet had this kind of clear translucency show through on the outside here, and this was a bright yellow part beforehand. But if I could show you how it feels on camera, I'd love to, but you can still feel that nice smooth surface. Moving to our thermoplastics, the powder beds all had very similar results, except for the rubber. So that TPU, that rubber-like material, did hold up very well overall with the abrasion. Maybe a little bit of rounding on those sharp corners at the top of the Bency, as well as around the smokestack here, but kind of looks like a part that you deliver, other than, of course, a little bit more staining than usual. When I look at my filament base, the softer material, this PLA, definitely had the most polish, where the ULTEM material, other than some staining, almost feels untouched. ULTEM is a very tough material by nature, and if you look at the feature sets across this, you're still seeing pretty pronounced layer lines, even across the smooth hull here, where a lot of these parts did smooth out significantly. I think it's important to talk about durability at this point. Durability can come through a couple ways. The first way is just being harder than the rest of the materials. If you're a really hard material, everything's soft to you. And that's kind of what happened with this ULTEM material, and that's my hypothesis on why this really stood up over a lot of the different materials over that aggressive a cycle. Or you can go with the flow. The rubber-like material was able to deflect and move as that pressure was going on it. So instead of abrading away, you still kept a nice matte surface because it was naturally rubbery. And if you look at a lot of instances where things are abrading a lot, that's what you're gonna find is very ductile materials like this thermoplastic urethane. So overall, I was expecting to see these things worn down the nubs. They weren't. But that's kind of cool because it also shows you how different 3D printing materials can wear and endure in certain conditions over pretty heavy abuse.
To further demonstrate the smoothing and erosion we noticed on these parts, we borrowed our QC department's optical comparator to get a close-up view of the Bency profiles. You can really see the smoothing effect we are talking about on some of the less erosion-resistant materials. For example, the layer lines on our PLA piece are significantly less pronounced on the tumbled Bency compared to our control. If we look at the profiles of the ULTEM or the TPU Benchies, the differences between the control and the tumble pieces are much more negligible. Beyond ink fading, the TPU wore a lot less than other samples. Polycarbonate wore a little less than the PLA piece, but you can definitely see the erosion on the bow of the ship. The smoothed out resin 3D prints had variable wear, and you can see on the smokestacks pronounced differences. Our clear SLA part was stained over the duration, with all sharp features smoothed to a radius. The outer lip of the hull was significantly worn on the Polyjet piece, as well as the front of the smokestack. LSPc XC was polished and significantly eroded, with even more wear on the front curve of the Bency. Our plastic powder bed parts had similar wear, but still far less than the resin photopolymers. Carbon DLS had dulled features, and you can see some of the smoothing compared to our control. The standard surface of a DLS part is always cool with its radial patterns due to a pixel-based curing. This was almost totally worn away and smooth after tumbling. If you're interested in trying any of the materials we've tested or any of the other dozens of materials we have available, head on over to Xometry.com and you can upload your part files and get an instant quote today. Be sure to check out our other engineering challenges and follow us for future videos. Until then, thanks for watching.